Hello, welcome back on the next lecture. In this lecture, we're going to talk about norms. Okay, so these are the prerequisites classes you probably should have gone through, and this is what we're going to learn today: the various topics. Okay, in this, so yeah, let's get started. I'm Professor Wu. Let's get going. Okay, so functions. Functions is a way of extracting information from vectors and matrix. Like we can think of it that way, where over here is a vector and q1 is a function. And let's say q1 is a function of max. So we are basically putting a vector inside a function and it extracts some kind of information. So max in this particular case is telling you what the largest value is within the vector. Min is another function where you put x in, it tells you the minimum value. Of course, you can put average as well. So the point here is you can put vectors or matrices into a function, and the idea of the function is that it will extract some kind of information. Now, we learned these three of them, and the point of them are pretty obvious. But today we're going to learn a very special function called a norm. Okay. In a sentence, the way we will say it is the norm of a vector is dot dot dot. Like the max of a vector is, the min, the average of a vector is. Here, we're going to say the norm of a vector. And you can picture as average, min, max. Here is the norm of x. So we put, once again, a vector x into a function, right? And we extract the norm information. Now, the norm is so special, right? So special that it merits its own symbol and understanding. So, like I told you, norm is just a function. So we can say we're putting x into the norm. Or we can be more specific and say we put x inside the norm function. However, like I said, the norm function is so special, it has its own notation. Okay, it's used so much, it has its own notation. And the notation, instead of writing norm of x, is these double lines. So when you see this double line, you can picture as if you put this vector inside a function norm. Okay, they're mathematically equivalent. You're putting a vector inside a function. However, because we use it so much, like norm, so much that we just use this notation. Now you may have noticed that this look very similar to another notation, the absolute value, which instead of double bars, we have a single bar. The absolute value is the same idea where you put a vector inside absolute value, and then because absolute value is so special, we use it so often, we give it its own notation, which is a single bar. Now, the fact that they look similar is not an accident. What happened is absolute value and norm are actually the same thing. Absolute value is actually just norm. They're the same, except absolute value is specifically in one dimension. Let's take a quick look. So over here, if we picture the vector 3, right? So the vector 3 is just going this direction, and the vector minus 3 is going this direction. Because they're one dimensional, you see, when we put them as the absolute value, we can write b absolute value, c absolute value, which is equal to 3. In this particular case, we can interpret the absolute value as the length. The length. So over here, what is the length of this? Well, 3. Even though this is minus 3 here, the length is still 3. So the absolute value can be interpreted as length. Now, that's for one dimension. What if we have higher dimension, such as this one, right? So this is 3, 4. So, so, so when you move on to a higher dimension, therefore you're dealing with a vector of more than one dimension. That's when we want to use norm, right? So how do we extract the length information from a higher dimensional vector? The answer is norm. So the norm is the same as the absolute value. It's just the length. But now instead of in one dimension, we're looking at a higher dimension. If you have a vector of any dimension and you want to find its size, its length, right? Norm is the function that extracts this particular information. Now, there are many different types of norms. There's this one called the LP norm. The way we distinguish different type of norms is through this subscript, right? So P norm, one norm, two norm, infinity norm. Now, you might be um, wondering, well, aren't we just finding the distance, right, from point A to point B? So why are there so many ways to measure the distance between point A and point B? Shouldn't there just be a single distance? And the reason is got to do with geometry. Distance from point A is not always a straight line, and that's the reason why we have many, many different ways of measuring distance. So if you let's say we have a start and an end, right? You're trying to go from start to the end. And if you happen to be a bird, in order for you to get from start to end, you simply fly. Okay? So, and therefore the distance is simply the hypotenuse of this. So one square root, which will give you square root of 2. So if you're a bird, this will be one way of measuring, which is called the L2 norm, or also known as the Euclidean norm. So over here, L2 norm, 2, that is if you're a bird. However, imagine if this green thing is a building and you are just a pedestrian walking. Well, in that case, you cannot walk through a physical solid building. What you have to do is go this way and then this way. Therefore, the distance is the absolute value of this vector plus the absolute value of this vector, which will give you 2. So you can see the geometry is different depending on whether you're a bird or a human, right? Now, in certain cases, so this one, particular one we just went through, is called the L1 norm. This is L2 norm, okay? So L1 norm, which was for pedestrian, L2 norm was for bird. Now, there's another one called L infinity norm. L infinity norm, in this case, imagine you're going for a nice long walk and you're simply picking the longest distance. So these are the possible ones, and you're picking which one is the longest. Therefore, you're picking the max of 3 of them. So in this particular case, it'll be 4. So the L infinity norm is the max value in absolute terms. So like right here, if it's minus 4, the distance will still be 4, right? So, okay, so that's why we have different kind of norms, because it depends on the geometry and the type of question you're asking. Now, these are the most commonly used norms. However, you have all of them equates to LP norm. So LP norm allows you to measure all the norms. All you have to do is plug in the number of L. So L1 norm is equivalent to plugging into 1 into this equation. So L1 norm, if you plug 1 in, then it'll be, instead of P here, it'll be power of 1, and P here will plug 1 as well. And it turns out to be the L1 norm. The L2 norm, you plug 2 here, and then it turns out to be the Euclidean norm, like the bird. Like, so over here, remember the summation of the absolute values, and then take the square root. L infinity norm is essentially finding the maximum. So all these norms that we learn can be broken down into, reduced down to just one equation. So the LP norm is the general equation for all the norms. Okay. Okay. There's a particular norm that is by definition not really a norm, but we still call it a norm just for convenience. And that is called the L0 norm. And that tells you the cardinality. Okay. When we say cardinality, what does that mean? Well, let's look at this vector. Well, cardinality tells you the number of non-zero elements. So this is not zero. 1, 2, 3. Therefore, since there are 3 elements that are not zero, then the cardinality is 3. And the L0 norm is also equal to 3. So this is just a convenient way of asking how many elements are not zero inside a vector. Okay, so LZO norm extracts that information. Now, these various norms, L1, L2, L infinity, all have alternative names that, depending on what field you're in, you will use. So L1 norm, which I prefer to call, is also called Manhattan norm, as well as taxi cab. So you can imagine you live in Manhattan, and the way you travel is through blocks, or the taxi cab norm, because you're like a taxi driver and you're driving around the blocks. The L2 norm is also called the Euclidean norm. That's when you're a bird and you can just fly over buildings. The L infinity norm has lots of names. There's uniform norm, maximum norm, supreme norm. These are all the same as the L infinity norm. Okay. All right. So at this point, why don't you pause the video and do a little practice, go through this, and see if this you can remember this. Okay. All right. I'm going to move on. All right. So to find these norms, let's say we define a vector. The way you can calculate this norm in Python is through this function called linearalgebra.norm, right? And you pick the order. So the order is the P. So the L1 norm, you just pick one here, which is equal to this. L2 norm, you put the order as 2. And L infinity norm, you put the order as infinity. IMP, INF. Okay? So that's how you're able to find the L1 to infinity norm. However, if you want to do the L0 norm, right, you just basically use this count the number of non-zeros, MP count non-zero, and it will do it for you. Okay. Okay. In the very last bit, now remember, previously the reason why we start learning NumPy is because with NumPy we can do calculations really quickly, especially when you have very large matrices. However, you can imagine you don't want to be typing a matrix of like 1000 by 1000, right? You don't want to type that in. So in real life, most of the time what we do is we have these data saved in a file, which we will call them the CSV file. So they're saved in the CSV file, which, for example, when you open the CSV file, it might look something like this, right? So this right here, when you load, you can actually just load this file in and set that equals to some x, right? This is a 4x3 matrix. So let's go over this code. We import some library, the NumPy library, and then I import this gen from text. Okay, this gen from text is useful because this function allows you to load the file test.csv with the delimiter of comma. What that comma is for is saying that the numbers are separated by comma. After that, if you print out the matrix X, notice how this is the same as this. So normally, you don't type the number in. You have some data and you load the data into some variable X, and then you can perform like various operations on them. So you can load them, and after you perform various operations, what you can do is you can export it. You can save some kind of, do some manipulation, right? So some manipulation on X, and then output some Y, and then you can save this into another CSV file, which we call Y, and then make sure whether this is integer or float right here. So if it's float, you use this one. Integer, you use this one. Okay. All right. At this point, what I want you to do is to pause the video again. You want to review basically what we learned. What I want you to do is go to the Canvas. In Canvas, there's a data folder. Like go to the data folder. From the data folder, you can find all the test files. With the test files, I want you to load them. And once you load them, you want to print them out, calculate them by hand, right? Calculating them by hand will be very tedious. And then you want to basically do it in Python, right? So this will give you a sense of calculating by hand is not fun. And then once you do it by Python, you'll see, confirm your result with Python, you'll see how easy it is. Once you do that, right, now you're ready to calculate the rest. So make sure you can do this like really smoothly, and I think that is it, right? That is it. Okay. So I will see you in the next lecture.